హాయ్ ఫ్రెండ్స్, ప్రీవియస్ లెక్చర్లో మనం ట్రావెలింగ్ వేవ్ ఈక్వేషన్ని డెరైవ్ చేసాం కదా. ఈ లెక్చర్లో మనం ఇంటర్ఫీరెన్స్ ఆఫ్ వేవ్ని చూద్దాం. ఓకేనా? ఈ ఇంటర్ఫీరెన్స్ ఆఫ్ వేవ్స్ అంటే టూ డిఫరెంట్ వేవ్స్ కంబైన్ అయినప్పుడు న్యూ వేవ్ ప్రాపర్టీస్ ఎలా ఉంటాయి అనేది స్టడీ చేయడం అనమాట. రైట్? Before going to interference of waves, we have basic idea about phase angle. Phase angle ante the angle between two waves, right? Phase difference between two waves. ante ఈ కాన్సెప్ట్ అర్థం చేసుకోవడానికి ఒక పార్టికల్ సర్క్యులర్ మోషన్లో మూవ్ అవుతున్నప్పుడు స్టడీ చేస్తే మనకి ఫేజ్ యాంగిల్ గురించి ఐడియా వస్తుంది. ఈ పార్టికల్ ఎట్ t=0 దగ్గర ప్రొజెక్షన్ ఆఫ్ దిస్ పార్టికల్ ఆన్ y axis 0. Here projection of this particle on y axis is 0. Y is equal to 0. The total time period అంటే ఒక రివల్యూషన్ కంప్లీట్ చేయడానికి ఈ పార్టికల్కి టైం పీరియడ్ టైం పడితే at t is equal to τ/4 అంటే క్వార్టర్ సైకిల్ కంప్లీట్ చేయడానికంటే ఇక్కడ ఉంటుంది పార్టికల్ ఇక్కడికి t is equal to τ/4. Then projection of this y axis is the amplitude of this length of this projection is a, maximum length is a. T is equal to τ/2, half of the time period. Therefore y is equal to 0 here, half of the time period. T is equal to τ/2. At t is equal to τ/4 అంటే ఇక్కడ again this projection is -a, right? T is equal to τ, y is equal to 0. Again here in between τ/4 and t is equal to 0, here the projection is here. We are taking 4 samples. Now we draw the graph, corresponding graph about amplitude and omega t. Omega t is the angle in the radians. This is π/2, pi, 3π/4, 2π, 3π/2, 2π. We get sine wave, right? This is a sine wave. Y is equal to a sin omega t, right? For plotting the graph between amplitude and time, we got y is equal to a sin omega t. Another particle, second example 1, example 2. Second example, now the particle is starting here, right? At t is equal to 0, y is equal to a, maximum amplitude. Here t is equal to 0, y is equal to 0. But same particle now starting at peak position, right? T is equal to tau by 4 here, y is equal to 0. T is equal to 3 tau by 2, again y is equal to minus a, right? And t is equal to 3 tau by 4, y is equal to 0. T is equal to tau, y is equal to a. If we draw the graph of this particle, we got like this. What is the difference between this graph? This is y2, this is y1. What is the difference between this graph and this graph? How we find this graph from this graph? If ఈ వేవ్ని 5 degrees ముందుకి అంటే అడ్వాన్స్ చేస్తే అంటే π/2 రేడియన్స్ అడ్వాన్స్ అంటే ముందుకు జరిపితే ఈ వేవ్ వస్తుంది, రైట్? నౌ the mathematical representation of this graph is y2 is equal to a sin omega t minus or plus. Advance, we are shifting the waveform by π/2 radians in negative direction. Negative direction means positive, π/2. Right? Advance, we are shifting this waveform π/2 radians in advance. Means here this particle is moving advance of π/2 radians with respect to y1. ఈ y1 particle కి ఈ పార్టికల్ π/2 రేడియన్స్ అడ్వాన్స్ లో ఉంది. సో రేడియన్స్ కాబట్టి π/2ని యాడ్ చేసాం. టైం అయితే t plus t0. Here radians. So omega t plus π/2. This π/2 is the phase angle between two waves. This π/2 is the phase angle between these two waveforms, right? This is the concept of phase angle. Phase angle means how many radians of angle advance or delayed. Delayed means minus. That means behind the wave, right? This is advance. We shifted this waveform in negative direction, so positive π/2, right? This is the phase angle. Phase angle means phase difference between two waves. Okay, let's say cos omega t, y is equal to a cos omega t. Now write the y2. Write mathematical expression for y2. Mathematical expression for y2 is equal to I am shifting this graph as wave π/2 radians in positive direction, right? y2 is equal to A sin A cos omega t. Positive direction means negative pi by 2 radians. I am getting this waveform from this waveform, right? So we can write omega t minus pi by 2 is equal to sin omega t. This is sin omega t. Shifting of angle. This angle is phase difference. Here, the difference between the two waves is called phase difference. In vector notation, how we wrote that phase difference means this is y1. y1, y2 is pi by 2 degrees lag అంటే డిలేలో ఉంది. సో నెగిటివ్ డైరెక్షన్ pi by 2 90 degrees or pi by 2 radians. This is the vector notation of these two waves, right? Okay. Our traveling wave equation is y of x comma t. Two variables are here. A sin omega t minus kx. This is our traveling wave. If we add two traveling waves, y1 is equal to a1 sin omega t minus kx, y2 is equal to a2 sin omega t minus kx. Only amplitudes are different, direction of two waves are same. That means these two waves are traveling in positive direction. y1, y2. మనము ఈ రెండు వేవ్స్ని యాడ్ చేయాలంటే ఫ్రీక్వెన్సీ అండ్ వేవ్ నెంబర్ షుడ్ బి సేమ్ ఫర్ టూ వేవ్స్, రైట్? ఇప్పుడు ఫ్రీక్వెన్సీ కానీ వేవ్ లెంత్ కానీ వేవ్ నెంబర్ కానీ చేంజ్ అయితే మనం యాడ్ చేయలేము. ఎందుకంటే ఇవి ట్రావెలింగ్ వేవ్స్ కాబట్టి ట్రావెల్ అయినప్పుడు ఆల్వేస్ దెర్ ఇస్ ఎ డిఫరెన్స్. ఒకటి ఫాస్ట్గా మూవ్ అయినప్పుడు అవుతుంది, ఇంకోటి స్లోగా మూవ్ అవుతుంది. కే చేంజ్ అయితే కే ఆర్ ఒమేగా చేంజెస్, వెలాసిటీ ఆఫ్ ద వేవ్ changes, right? Velocity is equal to velocity changes, right? So velocity change అయితే మనం యాడ్ చేయలేం. ఇది ఫాస్ట్గా మూవ్ అవుతుంది అనుకోండి, స్లోగా మూవ్ అవుతుంది అనుకోండి, ఈ పార్టికల్ని యాడ్ చేయలేము. ఈ పార్టికల్ ఆఫ్టర్ సమ్ టైమ్ హియర్, దిస్ పార్టికల్ ఆఫ్టర్ సమ్ టైమ్ హియర్, there is a difference in phase. సో మనం టూ వేవ్స్ని యాడ్ చేయాలంటే ఒమేగా అండ్ కే షుడ్ బి సేమ్ ఫర్ టూ వేవ్స్. హియర్ both waves are traveling in positive direction, only amplitude is different. So sum of y1 plus y2 is equal to a1 plus a2 sin omega t minus kx. Those two are in same phase. So y is equal to y1 plus y2, right? ఇప్పుడు సమ్ మోర్ డిఫికల్టీ, ఫేజ్ యాంగిల్ ఉందనుకో. ఫేజ్ డిఫరెన్స్ అంటే ఒక వేవ్ డిలేలో ఉంది, 5 degrees. ఇప్పుడు ఎలా యాడ్ చేస్తామంటే this is vector notation. How we represent these waves in vector form? This is y1, this is positive, right? y2. We know parallelogram of addition of vectors. This is y2, this is y1, this is the phi, this is the phi, right? Now this A net amplitude, by adding A1, A2, this is the A resultant amplitude. Resultant amplitude is equal to root over A1 square plus A2 square plus 2A1 A2 cos of angle between two waves, right? This is the net amplitude. We get net amplitude, but after adding two waves, what is the resultant phase? That resultant wave in phase with y2 or in phase with y1? No, in between y1 and y2. That means resultant of these two waves here starts between y1 and y2. How we find this new phase? Find this length is equal to y2 sin phi, right? This is phi, opposite side is y2 sin phi. This is y1, right? This is y1, this is y2 cos phi, right? Now this is phi, sorry, this is y1, y2, this is the resultant phi nu. Phi nu is equal to y2 sin phi by y1 plus y2 tan phi, right? Tan phi by 2 cos phi, right? This new phi, this is the phase, new phase for the resultant wave, right? Now the main topic is interference of two waves traveling in different directions, that is opposite directions. That is y1 is equal to a sin omega t plus kx, y2 is equal to a sin omega t minus kx. This wave is traveling in negative direction. This wave is traveling in positive direction. If we add two waves, one wave is traveling in right side, one wave is traveling in left side. When they are meeting, the new wave is appear, right? That wave is y is equal to y1 plus y2 is equal to a, same amplitude. We are considering both waves are having same amplitude, same frequency, same wave number, right? Sin omega t plus kx plus sin omega t minus kx, right? This is a sin a plus sin b, sin a plus b by 2, sin a minus b by cos a minus b by 2, that is sin omega t 2 omega t 2 omega t by 2, right? Kx minus kx gets cancelled, right? Into cos a minus b by 2, that is cos kx. Here these are two waves multiplied, right? This is y is equal to sin omega t. Let's say amplitude is 1 sin omega t. This is omega t. This is a time period, that is a total time period is tau by 2, and this is a tau by 4. This is a 3 tau by 4, right? This is position time graph, right? Position of the particle with respect to time. This is the graph. This is y. Let's say a amplitude. This is cos x, right? Cos x graph is like this. At 0 it is maximum. A. Y is equal to a cos kx, right? This is sin omega t, a cos kx. These two graphs are multiplied for getting final wave, right? If we multiply these two waves, we get this final wave, right? Here this wave is not a traveling wave. This part is not a traveling wave. This is an example of simple harmonic motion wave, right? This is not at all traveling wave, because there is no time function here, there is no distance function, position function here. So these two are not traveling wave individually, right? If I multiplied these two waves, what I get? Let's see, at time t is equal to 0, that means time, this is time position graph. At time t is equal to 0, this is the sample, right? At time t is equal to 0, sin omega t is 0, right? This is kx. This is lambda varying, right? K is equal to 2 pi by lambda, right? 2 pi by lambda. Let's say x is equal to, here cos kx ekkada 0 avuddi, cos kx is equal to 0, kx is equal to n pi by 2, right? 90 దగ్గర 0 అవుతుంది. So n is odd. n pi by 2 దగ్గర 0 అవుతుంది, n is odd. Kx. X is equal to n pi by 2 by k. X is equal to n pi by 2 into 2 pi by lambda, right? Pi gets cancelled. X is equal to n lambda by 4. N is odd here. N is odd. That means that x is equal to lambda by 4, x is equal to 2 lambda by 2, right? 2 n is odd, right? Sorry, 3 lambda by 4. This cost function getting 0. That means this is lambda by 4. This is 3 lambda by 4. This cost function getting 0 at lambda is equal to x is equal to lambda by 4, and this is position space graph. That means ఎంత డిస్టెన్స్ దగ్గర వేవ్ అనేది ఎలా ఉందో రిప్రజెంట్ చేసేది గ్రాఫ్ ఇది, రైట్? at x is equal to lambda by 4, the graph wave is 0. This is called node, right? This graph is imaginary. Position time graph is imaginary because we can't see the time, right? But this graph is physical graph. We can watch this graph because position space, that means physical quantity, we can watch this graph, right? At t is equal to 0, this term is 0, right? This term is 0. So total wave is 0 multiplied by this is final graph, right? Y is equal to y1 y2, let's say a sin omega t into cos kx. This is cos kx. At t is equal to 0, this term is 0, right? This term is present, but 0 into something is 0. So t is equal to 0. This line is t is equal to 0. At t is equal to 0, straight line. Okay. At t is equal to some t by 4. This is t tau by 4. Time period by 4. We get maximum 1, right? I get maximum peak, right? So peak into something. This is fixed, right? Position and space graph is fixed, right? This is varying with respect to time, but this is not varying with respect to time. I am varying the time and draw the graph of final result, right? At t is equal to 0, 0 into something is 0, right? At t is equal to tau by 4, I get the maximum peak. So this is 1 and cos kx. I get this waveform, right? This is lambda by 4, 3 lambda by 4. This wave is at t is equal to tau by 4. At t is equal to tau by 2, again this wave is 0, right? Again 0 into something is 0, and this is the wave. This is t is equal to tau by 2. At tau is equal to 3 tau by t is equal to 3 tau by 4. This sine wave is -1, right? A into -1 into cos kx. Kx, this is the graph, right? I get negative peak, right? Right? Yes. This wave is at t is equal to 3 tau by 4, right? Again at t is equal to tau, again 0. This is t is equal to tau. That means when time is passing, the wave is oscillating, right? Not traveling. This is a node. We can physically observe this node, right? In a stretched string, we can observe when two waves are passing in opposite direction with the same frequency and the same wavelength, we can see this type of wave, right? This is node and this is called anti-node. Anti-node, right? This node position does not change because kx, this is not varying with respect to time. So this x is constant, that is not changing with respect to time. Only amplitude of the wave, position of the particle of the wave gets oscillating. So the particle on the wave is oscillating from positive peak to negative peak. So this type of wave is called standing wave or stationary wave. Right? This type of graph is called standing wave or stationary wave. Here observe, this is the cos function, right? This wave is cos function. This cos function is varying with respect to time. But position of the graph not traveling, not changing. That means this is constant, right? We are adding here, we are adding two waves, right? What happened when I subtract these waves? That means when I subtract these waves, what I get? Y is equal to y1 minus y2. A sin omega t minus kx minus sin omega t plus kx. If I subtract sin A minus sin B is equal to cos A plus B by 2 into cos A minus B by 2. A cos omega t sin kx. Here we are multiplying y1 is equal to cos kx cos omega t. This is cos omega t graph into A, this is y2, A sin kx. This is displacement position graph. That means particle of the wave with respect to position, right? That means with respect to distance. This is position of the particle with respect to time, right? This wave is constant because there is no time variable here, right? At t is equal to 0, this is the maximum, right? 1 cos 1, right? At t is equal to 0, this is the wave 1 into sin. This at t is equal to 0, this is t is equal to 0. I am drawing position distance graph. At t is equal to 0, this cos omega t is 1 and we get at t is equal to 0, y is equal to a sin kx. That is here. At t is equal to This is, let's say, tau by 4. T is equal to tau by 4. At t is equal to tau by 4, y is equal to 0. Right? This is 0. This is a 0 into something 0. The final output is 0. Right? This waveform is at t is equal to tau by 4. Right? Again, t is equal to tau by 2, the negative peak, negative 1, cos omega t is equal to omega t is equal to pi by 2, at t is equal to tau by 4, tau by 2, omega t is equal to pi by 2, right? At t is equal to tau by 2, omega t is equal to 2 pi by tau into tau by 2. Now tt gets cancelled. Tau by 2, omega t is equal to pi, right? Cos pi is equal to -1. I get negative peak here. This is -1. At tau t is equal to tau by 2, half of the time period, I get -1. T is equal to tau by 2, y is equal to minus a sin omega t. Right? This is the new waveform at t is equal to tau by 2. This is the waveform. And again, tau is equal to, t is equal to 3 tau by 2, 3 tau by 4. Right? T is equal to 3 tau by, t is equal to 3 tau by 4, y is equal to 0. Because this is 0 and 0 into something 0. This is t is equal to tau by 3 tau by 4. At t is equal to 0, we are getting sine wave, and t is equal to tau by 4, get 0, and t is equal to 3 tau by 4, we are getting negative sine wave. That means the particle is oscillating with respect to time, but not with respect to distance. This is called standing wave. If we adding to waves or subtracting to waves, that means the same amplitude, same frequency, same wave number, we are getting standing waves, right? If we change amplitude, we are not getting standing waves. If we change frequency, different frequencies, we are not getting standing wave. This is called standing wave. This is not at all traveling wave, right? The node is fixed here. This node does not move because, see here, there is no time function here. Sin kx, there is no time function. So this node is not changing. This antinode not changing with respect to time. With respect to time, the wave is oscillating with respect to mean position, but not changing its displacement. Right? This is the standing wave. These standing waves are appear in stretched string and tubes. Right? Sound waves. We are getting standing waves in a sound waves, right? Sound waves also create standing waves, right? This is the lesson about standing wave. Thank you.